All right, so on today's warm-up question, we factored the top and the bottom, and we were looking for the coordinates of the whole. After this canceled, we knew that -2 comma something was going to be our whole, and so we stick the -2 into the equation, and we get -4 over, that's -1 times, that's 1, and that makes a grand total of 4. Did you guys get -2 comma 4? Okay, good. So that's how you get the exact coordinates of a whole. All right, next one, I taught you how to do these rate problems. Remember, it's a rate plus a rate equals a rate. And my recommendation is you always use the units in your first problem because they love to try to trick you and give you one part in like days and the other part in weeks. And if you don't keep all the units exactly the same, you'll get messed up. So if I put Taylor's rate right here, he can weed the garden. I would call that 1 garden in 4 hours. Go from there. I'm going to pause for a second while you try to answer this question. Okay, let's see if you did it the same way that I did it. So if Carl helps, well, that doesn't tell me much. So what do I write for Carl if I don't know how much he did? Well, I don't know how much he did, but they weeded a garden. He did 1 garden in some unknown amount of hours. Equals, they together, for both of them, it took them 1 garden was done in 3 hours. Okay, did I keep my units the same? Garden, 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 yup. Hours, 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 yup. So now I can drop those and just say 1/4 plus 1 over x is equal to 1 over 3. Do you get then it's just a clear the fractions kind of thing? Okay, so I'm going to times everything by 4 and 3 and x. Just changing colors to make it more clear what I'm doing to the problem. And now the 4's cancel, and the x's cancel, and the 3's cancel. And then I get 3x plus 12 equals 4x. And I'm going to subtract 3x from both sides. 12 equals x. Boom, I'm done. And what was x again? You can look up into your originally set up problem and see, look, x is how many hours it takes Carl to do 1 garden. Is there another way to set it up? For sure. There's probably 10 ways. And as long as you show your work, I'm going to be fine with you doing it a different way. I need to see one more time so I can get a count. How many people had the 12 without help from the other kid next to you? Okay, that's most of you. All right, good. Yes?
Could you technically use any number on top as long as they're the same? Like, for instance, if you got 12 of these, you're going to want on top, so there's 12
12 gardens?
Well,
Would that make any sense, though?
but it would give you the same number.
I'm just saying, would it make any sense that he graded 12 gardens in 4 hours? 12 gardens in 4 hours. 12 gardens. See, I don't think that makes any sense. So I'm not going to use a 12. But sure, I could have times everything by 12 is effectively what you're saying. And yeah, but I don't understand how it would make the problem better. Could I have also changed all of these hours into minutes by multiplying them out? Sure, but I don't think it would be better to change them all into minutes, but I could. All right, so I'm just saying, I think you should try to make it make sense more than just a way that works. Okay, so let's move on to this one. Now, this one is, I used to say there was a certain problem I thought was going to be the hardest one on the test. I'm changing my mind. This is probably the hardest one. They're close because the other one's more about just being really careful, and kids just aren't super good at that. This one's more like you got to think. All right, so we got to practice this one, and I got to help you. As if I just say do it, probably only 2 people will understand what's going on. So, but let's everybody read this. You can all read and understand the situation first. Okay, so I'll pause for a second. You read that really close. Make sure you understand it. Okay, so you've got this box. Notice it doesn't have a top. They're telling us that they want the volume to be 1,000. So I know a bunch of things. So I'm going to start with the formula that I know off the top of my head. Volume is length times width times height. The first thing you should do is write a generic formula from your memory banks. If you had to, this would be the part where you would Google. You can't on the test, but you'd Google what's the volume formula for a box, and then you put it down. Now we have to adjust it for our situation. Do we know the volume of the box? Yes, we do. It's what? So we put 1,000 underneath the volume. And then do we know the length of the box? Well, do they even use the word length? In the picture here, do they use length? No. So I always have said use the length to be the longest thing. So in our problem, that's depth. And I know there's more to it, but for right now, I'm just going to put D for depth. Width, did they give us a width? Yes, they did. They called it width, but they called it X. Notice I'm adjusting to what they told us. And height, did they use any strange word for height? No, they just called it height. There. But wait, they told us something else that I can use to modify this. Didn't they say something about the base of the box? Yes? So therefore that tells you what? The width and the depth are the same thing. So they said specifically to make the width X, so let's make the depth also X, and then we've got an X here. Do you get how I got that down to two variables? Only H and X. All right. Now, I'm going to just go one more step and just say this is X squared times H. Now, could I solve for H? Yeah. And what I want you to understand here is if you can get it down to two variables, you can graph that. And you're going to have a graphing calculator on this next test. And you're going to need one, not for this problem, but for the next problem that we do in a bit. So make sure that if you either have a graphing calculator with you or B, you know where to call it up. If you didn't bring your calculator, you're not a bad person, but would you please raise your hand right now if you don't have your calculator? All right, so those three people, you need to go right now and go into single sign-on and get the yellow folder open, and inside the yellow folder is another yellow folder where you're going to find a calculator, because you have to either have one on your screen or in your hand. You'll need a graphing calc. So if you get it down to two variables, you can graph it. But do you get I got to solve for one of the variables? I can't just graph this. There's no way to put that in the calculator. Your calculator has a y equals screen where you could put stuff in, but I don't even have a y. Could I just change one letter here to make it easier to graph? I can change it. They never told me what to call the height, did they? They never said height has to be H. No, they didn't. So can I change the height to a y? And now, isn't it easier to graph because it's got the same letters as we usually graph? All right. But wait, we have to solve it for y. So I'm dividing both sides by y. No, wait, that was dumb. Sorry. What should I have divided both sides by? X squared, very good. Now, 1,000 divided by x squared. If I rewrite this as y equals 1,000 divided by x squared, I've got my height. And this is a way of saying stuff that you need to understand because we're going to ask the questions this way on the test. The height is in terms of x. You don't have to say all the numbers that are with the x, but the height is in terms of x. Okay. Now let's go back and look at the actual question. Express the height as a function of the width x and state the applied domain. That's implying that x can't just be whatever I want it to be. You get what I mean? X has a domain. Well, at a minimum, would you agree that x cannot be 0? Would you agree with that? And just think about it. On a box, can one of the sides be 0? That doesn't make any sense. Okay, so it can't be 0. So x is between, well, to start with, would you agree that at a minimum it has to be between 0 and infinity? And it probably can't be either one of those. Okay, so there's a domain for x. Now, in the real world, though, do you get that x can't get too big, otherwise your volume won't be 1,000 anymore? And if x is too small, then the volume also wouldn't be 1,000? All right, so let's go on in the problem a little bit, and maybe it'll become more clear about why, you know, what that domain should be. It's more than just that, but that's a good starter domain. Okay. It says solve h of x, which is the height, is greater than or equal to x, and interpret. All right, we already have the height here. And we said the height was equal to that. They're now telling us, I don't really like how the problem is written, but they're saying that the height has to be greater or equal to that. The height needs to be greater than or equal to that, because that's what they just said. No, wait. No, they didn't. They said that the height, which, okay, has to be greater than or equal to x. Okay. So the height, which is this, hold on, the height is this, that has to be greater or equal to x. Now, do you get that looks a little bit like the problems I've been having you do where we go, okay, let's clear the fractions, but can you clear the fractions when you've got a greater than or equal to in there? In case you forgot, nope, you cannot just multiply by x squared on both sides because there's that in there. So how are you going to solve it? You're going to subtract x from both sides. Everybody take 1,000 over x squared. It's greater than or equal to x, and solve it like I'm doing right here. Pausing. So I hope you took away x on both sides, and then you got like this. Take away x. Greater than or equal to 0. Ooh, it's set equal to 0. That's a good sign. I hope you're getting used to that we always seem to set these things greater or equal to 0, or less than or equal to 0, or whatever. Does this have a common denominator, though? Nope. So then I got to go put this over 1, and then give it a common denominator. Nick, how would I get a common denominator here?
You can do x squared.
On the top and the bottom. I think that's what you mean, right? Okay, good. And then I can put all this together on the top. That's 1,000. So Stellar, why don't you just start with that? 1,000 minus x to the third all over x squared is greater or equal to 0. Now we'll take it from there. So what we're doing now is, do you remember this deal where we have to get a number line and we figure out what makes the top 0? Because that's called the x-intercept, good. And what makes the bottom 0? Because those make the vertical asymptotes. So what makes the top 0? What makes the bottom 0? And we put them on this number line. And then we'll have to test. And then we'll figure out what the domain for x is. It'll tell us that x has to be between this and this. Okay, so what makes the top 0?
10.
That worked out pretty nice because 10 times 10 times 10 is 1,000, and so awesome. Did you actually solve that by guess and check, or did you do something else? Awesome. 1,000 minus x to the third has to equal 0. And then you add negative x to the third had to equal negative 1,000. And then x to the third has to equal 1,000. And at that moment, it wouldn't have been any bad thing to go, oh yeah, it's 10. But you could have also done cube root, which looks like this. But even easier than that is putting it to the 1/3 power, which is also a cube root, because that can be done in the calculator a little easier. And then you get 1,000 to the 1/3 power is 10. Yay. So 10 is one of my numbers. I'm going to put it here. Because the other number is what makes the bottom 0, which is 0. And I'm putting a dotted line because there's an asymptote there. Okay. This is what I used to think was the hardest problem. But do you see how it's in the middle of a word problem? Then that makes the word problem the hardest problem, because you have to do other stuff and then solve one of these. All right, so now my answer is, it's empty spot there. Can it be 10? Because this says or equal, 0 is an okay thing. So then my answer is, now let's just think logically. Can I tell whether this is between 0 and 10 or between 10 and infinity? Do you think that our x value should possibly go to infinity? That doesn't make sense. All right. So, how about this? Since it's an x to the third, and if I were to sketch this, I would bet it goes something like this. And wait, there's a triple root, so then that makes 3. I better not try to do that. I'm just guessing. But I better check the numbers between 0 and 10 to make sure it works. I'm going to put in a 1 and see if it works. So I go back into my equation. I put in a 1 just to see if 1 would work. I put in a 1 right here, and I get 999 over 1, and that's definitely greater than 0, so it works. So this is my zone. Do you get why x as a new, better domain has to be between 0 and 10? Because 10 is the biggest it could be. Because if you use 10, you're going to get a volume of 1,000. And if you try a number bigger than 10, it won't make this greater or equal to 0. So you'll realize that doesn't work and this doesn't work. Okay, yes?
Do you have to show yourself testing like the outside parts, or can you just say, like,
Nope.
you can't go to infinity?
Nope, you don't have to show yourself, testing all of the regions. You just have to be right on which regions worked. You have to show that. So if I show that 1 worked, like I just did up here, then I'm good. Okay, I know that was complicated, but yeah, these word problems are not super easy. Now let's talk about what this means. This is height, and I always find that it makes sense if you change these into what they are. And this is like, well, x is like the width and depth. As x gets closer and closer to 0, you don't know what that little raised plus means, that's okay. As x gets closer and closer to 0, x is getting smaller, smaller, smaller. What do you think the height is doing? As x gets really, really, really close to 0. Remember, the volume has to be 1,000. If I make that base smaller, 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 but the volume has to be 1,000, do you get the height has to get bigger? All right. So what is the behavior of the height as x gets closer to 0? The height rises. It increases. Does it go to infinity? No. It gets closer and closer to it, though. All right. And as x, which is the width, gets bigger and bigger and bigger and bigger, if you make x bigger, 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 wouldn't the height have to get smaller, 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 smaller? So I interpreted that because I used the words like height and width. if you have to do this on a test, I just recommend you figure out what is x again. In this case, it's the width or the depth. As the depth goes towards infinity, then the height has to shrink. All right. This is the last one we're going to do here, and then we'll move on. The surface area of the box as a function of x. Surface area is normally, I know a lot of you are weak at these formulas, but you're going to have to do this on the test, so memorize this. You ready? The surface area is 2, and my dimensions are x, y, and z. X is the height, x is the width, y is the height, and depth is also an x, which is a little weird, but 2xy plus 2xz plus 2yz. Basically, there's 2 of every side. That's the generic general surface area formula. Do you get what I mean? There's 2 of this kind of side, there's 2 of that kind of side, and there's 2 of the other kind of side. If you have a box, you get how there's 6 sides, and that adds up to 6. See what I mean? 2 of these, 2 of these, 2 of these. But this one is special. So underneath this, we put in what we know. Did they tell us a surface area? No, they didn't. So we leave this as SA. And you could have just picked a letter if you wanted, but I like surface area for SA. And 2xy is fine, but 2xz doesn't make any sense. We don't actually have a z. Z is really also x. And the weirdest thing of all is that the side that's xx, that's, I'm going to shade it in here. That's this side here on the bottom. Do you get that there isn't a top? So there isn't 2 of those sides. There isn't 2 xx's. There's only 1. Plus 2y, and z doesn't exist, it's really x. Whew, that was intense. But wait, that's got 3 variables. You can't graph something with 3 variables. You got to get it down to 2 variables, then you could graph it. Martin.
So usually if a box has a top, you would count the outside surface area. But since this one doesn't have a top, do we also have to do the inside?
That's an excellent question. No, it's outside surface area, but nobody's ever asked that before. It's a good question. Technically, there is area on the inside of the box and the outside of the box, and they're just talking about the outside area of the box. All right, so back to, if I'm going to solve this thing, I've got 3 variables. I got to get it down to 2. Come on, somebody figure out what we can do to get it down to 2 variables. What? Nope. Thank you for trying. That you can add them, but it doesn't get rid of a variable. How about this? Let's add them. I like it. She said, can't you just add these 2? Yes, it just doesn't make me have less variables, but let's do it. I like it. Surface area is xy and xy. Those are just reversed. They're the same thing. You can reshuffle them if you want. So it's going to be 4xy's plus xx, which I could say x squared, right? But I still got 3 variables. So how do I fix it? Ooh, somebody's noticed. Oh, nope. Factoring's awesome, but it doesn't get rid of a variable. Yes? Boom, she remembered back here that y was 1,000 over x squared, right? So wherever you see a y, you could put 1,000 over x squared. So I see a y right there. So surface area is 4x, and then instead of y, I can put 1,000 over x squared plus this x squared, and I can simplify this even more because now I see that there's x's here and here, and so then let's get a final answer. the surface area is 4, and then one of those is going to cancel, times the 1,000 is 4,000. Remember, the 4 is really a 4 over 1, so I'm trying to 4 with the 1,000, it makes 4,000 over x plus x squared, and I could even get more fancy if I wanted to get this to have a common denominator. Kind of depends. I'm going to say sure, it won't take me that much longer to give it a common denominator. I'm going to times by x here, times by x here. And now I have surface area is 4,000 plus x to the third all over x. Do you get that is something you could graph, especially because you could change the surface area to be y, and look at that, you could graph that, couldn't you? All right, now let's talk about that actual process. Let's take a minute. We don't have to be awesome at this part yet, but you will by Tuesday. That's when the test is. You got to be able to find a graph of something like this. So let's do that. And the first thing I want to remind you is I would want to put all of this in parentheses, because otherwise when I put it in the calculator, it's going to think that the 4,000 is separate, and then you're just taking x to the third divided by x. So everybody put it in exactly as you see it right here on your calculator's y equals screen. Parentheses, 4,000 plus x, and the x key is the one by the alpha key, x to the third and then I'd put my in parentheses, divided by x. So here's what my calculator looks like. My y equals is over here. I got a parenthesis, 4,000 plus x to the third, parentheses, divide by x. All right. Now if I hit graph, it's very likely that you're just not going to see this graph. It's not going to be on your screen. Think about this. Do you get we just graphed something that had 4,000 in it? Do you think your graph is set up to be able to see the number 4,000? No way. So if your graph is set to see anything, it's usually set to see between 10 and 10. How in the heck are you going to see something that goes to 4,000? You have to zoom. Everybody find the zoom key. It's at the top of your graphing calculator. And go zoom out. And if you hit zoom out once, it doesn't do anything. It's asking you to say, where do you want me to zoom out? And it pulls a little cursor up. So you go zoom out, enter. And now I've zoomed out some and I still can't see it. Oh, now I can start to see it. It went flying past, but I saw something on my graph at least. Now I'm going to zoom out again. If you just keep hitting enter, it's going to keep on zooming out. And here's what I finally saw when my graph got zoomed out far enough. I saw this blue line going down like this. Do you guys see a line going like that?
Yeah.
And then do you see a little whoop right there? If you don't, you haven't zoomed out far enough. You'll see a little part of the graph that's over here. In the real world, you don't have negative lengths of sides and you don't have negative perimeters, so that just kind of makes no sense. So we're focusing on just this little part right here of the graph. All right, in order to get to our next problem, I want to keep moving, but from here it would be about zooming in, zooming out until you could finally see something in quadrant 1, because think about it. Quadrant 1's the only one that makes sense because it's got positive perimeters and lengths and volumes and lengths of sides. So you're going to want to zoom into quadrant 1 until you finally see the graph there. you can absolutely zoom into just quadrant 1, but if you got to go far enough out until you can finally get the really big numbers to see it. So, all right. How many of you were able to successfully find this little part right here? Raise your hand if you were able to find that. All right. If you weren't, I'm going to give you exactly what you can type in your window to be able to see it. Okay? I think this will be really good for some of you. I know on the test that some of you will need to adjust your window. Everybody find the key called window. Everybody go to window. Now, Martin, I think you said that you had a particularly decent view of it on your calculator or not? You do or you do not? Oh, okay. You do now or you do not? I can't hear you. Okay, good. Then why don't you tell us your window, but I'm going to just say X min. Didn't I just say a second ago that you don't need negative numbers? So what's the minimum X value you would want? 0. Okay. X max. That's a little trickier to know. But Martin, what do you say for your X max? What do you have? And you can see it pretty good? Okay, we'll do 160. I have something bigger, but I think 160 ought to be fine. Next is X scale, and always keep that as 1. Now let's talk Y. Y min. Do you get that there's no reason to have a negative Y? So 0. Y max. What's your Y max, Martin? All right, I can buy that. And then your Y scale, always keep it at 1. Everybody try those values, and then, as long as you typed your equation right, you will see the graph. When you put that in, as long as your Y equals screen graph was right, you should see a little graph like this. Raise your hand if you got it to work now. All right, several people that did not. I want you to now compare yours with the kid next to you and let them help you if yours is not working. You don't have it. Maybe your Y equals screen's messed up. Maybe your... I wouldn't necessarily say that's the right window. Did you change the window like I just suggested? You don't do that at the window. Because you can use logic to figure out that you can't, the minimums should be 0 because you can't have negative values.
How do you know how high to go on a test? Our calculator doesn't typically.
Oh, yeah, that's the second line.
In the end, I can't tell you what the window settings to use. You have to figure that out. Do you want to say this QR program? Yes, ma'am. Now it's completely refreshed. Like new. You have to retype in the equation. Whoa. Anybody else wants a little help? Because you can't get the U to show up? Oh, yeah, make the equation. You got to take them in the equation. So put a parentheses, there you go. Yep. Alright, I'm gonna go to programs, make sure you don't have any programs. Can I get rid of that program? It's probably just not good for you. Okay, now it's like factory new, so this should be great. So right in here is where you take the equation, starts with parentheses, and if it's 1,000, blah, blah, blah. You have that written somewhere? All right.
Yeah.
Awesome. It's 4,000. So can you show her the equation? That equation. Did you do it too? Yes. Anybody else need some help? then use these window settings. If you hit the window button after you, some people are just frantically typing this in right now, so I'll leave it up there for a second. Okay, so, big picture, this is the last thing. And all it is a word problem where we have to type it in the calculator. This is the last thing. And then Monday's review, and then Tuesday's the test. Okay, so here's the big picture. All right, so for those of you that are still trying to get this, what does this do? Well, it depends on what this is. Is this like amount of time you spend in the garden, and this is how big the plants grow? Well, no, of course, not in this case. X was how long one of the sides was. Okay, and Y was, weren't we doing perimeter?
Surface area.
Oh, surface area, that's it, surface area. So this is surface area. We did start with volume, you're right, but now we're on the surface area thing. So it's surface area equals blah, 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 and it was, what was this, blah, blah, blah? It was about X. It was about how big that base is and how much surface area you have. And why would we want the lowest amount of surface area? Think big. Let's say that you're boxing up iPhones and you make 400 million iPhones. Do you want to use as little cardboard as possible? Okay, so they're going to maximize their profits by having, and least waste by having the least amount of surface area. So that's why you want to find the lowest spot. All right, so then this is the last calculator skill I need to teach you, is how do we get this lowest spot? It's second key, calculate key, and then once you're there, I'd like you all to ponder this for a second. Second, calculate. Calculate's up near the top, near the trace button. So second key, and then the calculate, which is right above trace. If you did that right, you have 5 word choices. Value, 0, minimum, maximum, and think about it, which of those applies here? What are we looking for? The minimum. Very good. So everybody choose minimum. You can either arrow down to it or just hit 3. Now, this part, it says left bound. What that's saying is set a left boundary and then a right boundary, and then it'll tell you what the minimum is between those two boundaries. So you move your little arrow keys until you can see the little spider, which will kind of look like this. And if you look on the bottom, you can see where your X numbers are. And I'm going to say a left bound. Keep your hitting until X is in the neighborhood of 16, 14, 12, 10, 9, something like that. X is around 9. If you get X to be around 9, you'll be on the left side. Your little blinky spider will be like where mine is. You'll be to the left of the low spot. And you hit enter. And that puts in a little line. And then you go to the right of the low spot. I'm going to do mine around 19. So mine's around between 9 and 19 are my left bound and my right bound. As long as you are to the left of it and to the right of it, you're good. Then it says guess. That means move the little spider until it's right about where you think the low spot is. So right now I'm moving my little spider to be right about there. And then you hit enter. It says for me, minimum is at X equals 12.6. And what does that mean? 12.6 chickens? 12.6 centimeters is how big the box should be, or inches, or whatever this was. Feet. Can't remember what the units were, but 12.6 is the size of the bottom of the box. Centimeters, thank you. And then Y is the what? Surface area, good. And Y is 476.2. So again, if you think of this in terms of you're going to make 1 million boxes and you want to use the least amount of cardboard, That's why you'd want to find that minimum spot. All right. So that is the hardest thing. I'm going to show you a couple you should try for homework tonight. And I want you to do one of them in class where I'm still around to help you, because we still have about 10 minutes left-ish. I'm going to recommend that you do this one. It is a nice, normal one of the kind that I thought were going to be the hardest ones on the test. But now I have to say I'm wrong, because you do a word problem to get to this point, then that word problem must be the hardest problem. Okay, so anyway, this kind is the kind where you have to subtract one from both sides and then get a common denominator, and you end up with a number line, because this is like the tip of a number line, you know? You end up with a number line and a couple numbers. Whatever makes the top 0, whatever makes the bottom 0, those will be these two numbers. And then you got to figure out whether you shade in between them or outside of them. All right, so that's a reminder about how you do that kind. And I just do one minimum. If you need to do more, do more. Next, on this page, this is the big one that you need to do tonight. Unless you're saying, it's too hard, Mr. Server, I'm giving up on that kind. Don't give up. These are not that hard. You can do this. You're going to set up an equation, and I'll get you started. So I'll start this problem with you. Do you see how it says the area is 100 square feet? Would you agree that here's the generic formula for that? Area is length times width. But in this problem, we got to stick in what we know. Area is 100. Length is not length. What should we call length? The longest one. Which one's the longest one? X. Times, what's the width then? Y. Yay, we got one equation. Now, if that was the only part of the question, cool, you could solve for y and you could graph it and all that stuff, but that's not the only thing. They also say they want to minimize the amount of fencing she needs to buy. Okay, so the amount of fencing is a perimeter. Here's the generic formula for perimeter. 2 lengths plus 2 widths. But wait, we just figured out length was x. And width, oh wait, I shouldn't do it there. I should actually do it underneath it. Perimeter is 2, and instead of length, I want to put x, plus 2. Instead of w, I want to put y. And that's neat, Mr. Server, but you can't graph that because it's got 3 variables. So what do? You solve this one for y, and then you can put it right there, and you'll only have 2 variables, so you can graph it. I would recommend you change.
There's only one x.
This perimeter can be changed to a y. And, oh, you're right. There's only one x, not 2 x's. Good call. All right, so there's a start of that problem. I get some of you are not motivated enough to go do that tonight, and that's kind of sad, because then you'll for sure get it wrong when we take the test. All right, that's all I got for you for today. Have a great day.